Good morning. Welcome to the ZoomTown experiment. This will be another unique episode. In this particular episode, we're looking at a sensor called the Tiny Code Reader by Useful Sensors. One of our viewers suggested we take a look at it, and as soon as I heard what it could do, I thought, wow, this could help us out in a very unique way. And I thought, well, it's the ZoomTown experiment. We're kind of about doing things in a unique way. So several of us in the comments chatted about it there in an email, etc. And thought, wow, there's some really cool potential in this sensor. So I quickly went about looking into it. Now first, what is it? It is a QR code reader using a digital camera and an RP2040 to process the image and communicate the data via I²C. How cool is that? So it's got a camera and it's got a Raspberry Pi PICO RP2040 chip on it to control all its logic. Very cool. And it is a $7 sensor, which at first seems like, well, especially for this project, it is a very expensive sensor. A lot of them cost less than $1. So, but what does it do? It can read a QR code and interpret what it says and communicate that data, text data, to another microcontroller. In our case, the Zoomie. That's a lot of power. Now, QR codes, as you're probably familiar with, are these gizmos, and they can be made in just about any size. And frankly, they can contain a very large amount of data. For our uses, I really need less than probably 25 characters, and I'll show you what that would look like here in a minute. But these were various sizes that I printed and tried. Started out big, worked my way smaller, 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 smaller. That was a size that quit working. That's less than 3/8 of an inch, or about 9 millimeters. This one here is right around 13 millimeters, or about a half an inch. Actually, just a little bit smaller than that. But that actually worked. Now, so we have a thing of perspective here. This particular barcode contains, let's see, 3, 7, 14, 15, 16, 17, 18, 19, 20, 30, about 20, less than 25 characters of information. And I printed it out as close as I could to a ½ inch. It's just slightly larger than that. So it'd be a ½ inch square, or about 13 millimeters square. And that was the one I did a lot of my testing with to get to this point. Well, if that's the barcode, you can imagine what's the sensor and why is it a tiny code reader? Well, you're going to love this. Let me see if I can get the camera to focus on this thing. There it is. Okay. There's the little box for it. Well, I'll try to shoot this later and get you close-ups of what this looks like. I'm going to take it out of this cute little tiny box. I do not have gigantic hands. It is actually this small. You see the RP2040 there? This is a quick connector. It's got a header rail here, which can actually be snapped off if you're using that connector. For our application, I'm probably going to use that, but we'll see. And there is a tiny little camera that does all the work. $7. Camera, some other required components we see here. RP2040 for our microcontroller, and that is a QR code reader. Just awesome. It is so cool, this tiny little package. So how did we get to this point of me testing it? First off, I already mentioned that this is a good value at $7 US. I mean, think about that. Everything that's there for $7, including the code to interpret the QR code into usable data, text string data that can send out via I2C. Well, immediately upon Steve talking about it, I had to go find out who is Useful Sensors. Never heard of them. Went to their website. Rather minimal. Went down here at the top. This is the front of it. Products, QR code reading, zip on down. And this is kind of the information they provide, but they do have a link to a developer guide and a data sheet. And that's always a great place to learn something, or so you hope. It does tell us a little bit about it. This is the data sheet. Biggest issues were the size. Weight isn't really important. Needs 3.3 volts, perfect in our world. Logic is 3.3. Maximum current is 40 milliamps, so you can pretty much bank on it being quite a bit less than that. It requires 4 wires. The interrupt is not used. And then it goes into that there's a 254 byte hard limit on the code size that can be recognized, which is irrelevant for our concerns. Does like to work in minimum lighting levels, so I can't use high intensity spotlights around it. I haven't tested that yet. I2C communications. There wasn't a lot of information in here that helped me with what I was looking for. Some features, photo or 3D images of it, certs, and further docs leading to the developer kit, which should be this document. This had everything I needed to learn about it, and pretty well documented with some great examples. Of course, I went straight for MicroPython. In here, they had an example in MicroPython, and I'll go to that page. Lo and behold, it's even for Raspberry Pi Pico W. Not that it really matters, because wow, it is simple. So we'll get into that in a little bit here. Well, the next thing, of course, I'm hooked. I got to get one, so I go to one of my favorite suppliers, Adafruit. Found it there, $7 in stock. Nice thing about Adafruit is they often have some additional documentation from their perspective and examples from their perspective. What I mean by that is CircuitPython instead of MicroPython. Really irrelevant to what we're dealing with here, but it's always great to support suppliers such as Adafruit and SparkFun. These people create a lot of products that we use, and I buy from them whenever I can. But anyhow, I found it, ordered it right away at $7. Who could pass that opportunity up? The next thing you'll need is a QR code. I went to a website called QR Code Generator. You can create your QR codes for free. Can't beat the price. You literally type in what you want here. It creates this, and you can download a JPEG that you can then put in a document, print out, such as I have done here. Now, the coding format, this was just a fast stab in the dark of what I kind of am thinking. This QR code I'm planning to use for absolute data information. So, for example, as the Zoomie passes by this QR code, that QR code was printed with the X and Y coordinates at that specific location, along with a heading. So if this is in the northbound lane, that would be northbound at this X and Y coordinate. So that kind of really limits the number of characters I really need. That's 1/1000th of an inch resolution for the inch world, which is I'm going to try to do this in my head, I think it's 0.004 millimeters. 0.04 millimeters. Very small amount anyhow, very fine resolution. The overall layout of ZoomTown is 96 inches by 48 inches. So those two numerical sets of data covers every square inch of the board, and then adding in the heading protocol as well, or the heading information. So QR codes are easy to make. Let's go over some of the information that I've garnered in my testing so far. And I've only had the sensor in the shop here with me being with it for about an hour and a half. It was that easy to get up and running, set up an environment to test it, and the whole 9 yards. So I'm pretty impressed with this thing. It's 3.3 volts, less than 30 milliamps. It's certainly tiny. The sensor is 3/4 of an inch by a little over 5/8 by almost 7/16, or 19 by 16 by 10 millimeters. Simple to use. There is no library needed, which is so rare today. It seems like everybody wants to create this monstrous library file to operate their sensor. And in some cases, it's truly required. There's just no way around it. In this particular case, we're just extracting data from the sensor, so it's quite straightforward. But I do really appreciate the fact that a few lines of code and I'm sucking data out of this sensor. It reads QR codes as small as a 1/2 inch, as I've pointed out here. And its recommended sensing range is from 4 to 6 inches, which is 100 to 150 millimeters. So just to give you a perspective, that's 6 inches. So this is the range from the sensor that you need to be looking approximately. In truth, I got it reading all the way down to 2 3/4 inches, so 50, almost 70 millimeters, right around there. So it's quite dynamic. Now let's go on and look at some of the other attributes of it. It runs at a max frequency of 50 milliseconds or 20 hertz. That means the sensor's actually in that time frame going through processing an image that it just took. It's constantly grabbing an image, processing it, and preparing data to send out. And it can only do that every 50 milliseconds or 20 times a second. It doesn't mean it takes that long to access the data, just I can't read any more frequently than that. Now, in our world, we're moving, and this is where things get a lot more complex, but in that 50 milliseconds, the Zoomie moves 410 thousandths, which is 10.4 millimeters, or 7/16 of an inch if you're a fraction guy. The time to read the code is 8.18 milliseconds. So that's just the time for me to make the request for information, get it back, and do the required decoding for U28, etc., or U8, etc., so that we can look at the data in a way that's meaningful to us. Well, in that same amount of time, the Zoomie moves 0.067 inches, a little more than a 1/16 of an inch, and that's 1.7 millimeters. So there's going to be built-in error in this whole system. Realistically, that the difference between the 0.410 and the 0.067 doesn't seem to mean that much, except this. If I can only access it every 50 milliseconds and the Zoomie's going at full speed, its resolution will be 0.4 inches, because it's got to take the picture, convert it or decode it, and send the data, and then I got to decode it again and then look at the data. That's going to take at least 50 milliseconds, and in that time frame, the Zoomie's already moved 10.4 millimeters or 400 thousandths of an inch. So that's kind of a drawback. And actually, it's a very serious problem. But the scan area is really hard to determine, and this will make a little bit more sense, but if you can imagine the code is in the middle of this, I got about a 2-inch wiggle room around that QR code where the camera will see it. I have no idea what the resolution of the camera is. I'm sure it's got a part number on it, and I could probably track it down at some point, but for right now, it's not that important for me. And it can scan while moving. I did find that out. I could actually move it across something, and it would take, if I'm going slow, it could take several images of it and report the data from it. But you got to move slow enough so that you don't, if you go really fast, you'll pass by the QR code before that 50 milliseconds has an opportunity to take the picture. So that I haven't tested either, to see how fast I can go and still capture images reliably. We'll go over this analysis summary here after we look at it in a little bit more detail. This is my little test fixture. I took one of my Zoomie bodies, taped a lollipop stick on there, and wired up a few wires to the sensor, ran them back to the PICO, and taped it all on top of a body just so I could kind of get it over there. Now the body for the Zoomie is 4 3/4 inches, so about 130 millimeters from the bottom up. It's actually a little taller than that when it's on the wheels, but this just provided me with some means of testing this. We'll get into where we might position the QR codes a little bit later. Let's dive into the code here and see what we got. We're going to import a couple of libraries, nothing external, just internal libraries. We're going to specify the address in this variable. You'll notice all these huge variables here in cap letters. These are all just variables that are needed to start up and get the tiny code reader up and running. Some of this isn't really needed in our application at this time. I didn't really care. What this application was actually for, their demonstration, was for it to scan a QR code and then have a PICO-W go to a website and fetch data. I don't need that. I just need the ability to get the data out of it. So you'll see some of these formats, etc., aren't really needed for what we're doing. But that's all just configuration data. Here's the hardware setup for it. We're running it currently on pins 5 and 4. And the question will come up, do I have an I2C interface available? Actually, I have 2 of them. I'm using 2 different hardware interfaces, and I can have multiple devices on each interface. Currently, I've got the 2 encoders that use exactly the same address, so I had to split them up between 2 hardware different I2C interfaces. At the time, I was smart enough, we'll call it that, to add in an extra location on each one so I could put in additional I2C devices. I got lucky. But that's what this is doing, setting up the hardware at a frequency of 400,000 400 hertz. And here is my code. Now, there's some of this isn't even needed for what I'm doing, but it's just a skeleton of what was there from the what is it called? Useful Sensors. Forgot their company name. We just got a loop going here. This is a time sleep. That's that 50 milliseconds I was talking about earlier. You have to wait at least this long before requesting new information, because it takes that long to create the new information. This you'll probably recognize from my normal coding. This is just a flag for a start time and an end time, so I could measure how long this took. Therefore, I got my 8.18 milliseconds. But we're just going to read from it at the address, how many bytes. We're going to unpack it. I think some of that went off the end. Nope. And then another unpack from there and end it. So that's all we did at that point, and I have the message string to look at. Now, every so often, I am going to just increment this counter so that we can see the count number going up, because I'm just reading one barcode. It'd be impossible to detect if I'm reading the same barcode to see if it's making multiple reads. one of the old stupid tricks you got to do. But realistically, it's right here. That's it. Now I can just say message string equals that, decoded into UTF-8. That was the encoding I was trying to think of earlier. And then print it. And I'm printing that counter, the message string, the actual message itself, and then the difference in time it took between the start and the end of the gathering of the information. And this is just another one of the leftovers from the original example program. In our case, we're decoding these just fine. So I am going to plug this in and demo it. Clear that. Hopefully my lollipop won't fall off and parts everywhere. Now, what you will see, hopefully the camera will pick it up. You can see a little LED. It's actually blue in color blinking right there. And it just does that constantly. That kind of is how you know it's actually up and running and operating. So now what I'm going to do is just drive the Zoomie over. There we go. Just got to get over the QR code and have it running, and all of a sudden, magically, you can see the code being read. Now, off the screen there, you can see that the left column here is just the number of reads, my X coordinate, my Y coordinate, and then the actual time it took to read that data. And that time has nothing to do with the wait time up here where we're sleeping. So in our case, I would just put that in my main loop and only do it, which is right now 6 milliseconds. I would only access this thing once every 4 or 5 main loops, so that at least 50 milliseconds passes by. But as you can see, I'm going to move this around a little bit, and hopefully I can do a split screen. So you can see I've got quite a bit of positional error I can have, and yet still read that QR code. And yes, it's reading while I'm moving it. So all around, I am really impressed with this sensor. Unfortunately, as cool as it is and as great as it works, we may have a problem. So let's take this to the next level. I'm going to get this cable out of my face here. Now what I've learned, and that's going to be the important thing. Every time I try out a sensor, I got to learn a lot about it before I'm willing to play with it and use it. One, as I mentioned, the Zoomie has 2 available I2C interfaces still available, so I can put 2 of these on the Zoomie if I need. It's going to really get expensive. It can read codes containing our location data, which I just showed, X and Y coordinate data. The time to read the code is a problem at 8 milliseconds. Remember, I originally wanted 5 milliseconds. I bumped it up to 6 milliseconds to try to, my main loop, my deterministic loop. In this way I've got the system structured now, it's less of an importance, but that is we'll call it a parallel experiment. I still want to work within a deterministic loop. It's not as critical with the methodology I'm using for the Zoomie control program as it is today, but I still want to continue with that experiment so I can learn on that as well. But that 8 milliseconds is a lot of time. The position where the code is read will not be precise, will be plus or minus 10 millimeters estimated, 10 millimeters, about 3/8 of an inch. And why is that? Remember, it can only read the device every 400 milliseconds. So in that time frame, the device or the Zoomie's already moved 400 thousandths of an inch, or 10 millimeters. And therein gets to be a problem. I had the same problem with the magnets that I'm using regarding our absolute encoder system, my hybrid system I came up with there. So there is a workable solution on that, but that's a little further down the road. The QR code must be 4 to 6 inches, 100 to 150 millimeters away from the sensor, and as you saw, it worked good at that distance, and as I mentioned earlier, I was able to get it closer, not much less than 2.5 inches, and certainly not much greater than about 8 inches. That seems to be its sweet spot, and that's relative to this QR code that I've made here. That's the important, I think, controlling factor. If I want to use this in motion, I must be moving very slow, but most realistically, I think I need to be stopped in order to read this. One, the amount of time to read it. Two, is that 50 milliseconds, and the distance moved in that time frame really messes up where you think you are relative to what the sensor is telling you are. That's a big, big problem. But I got an idea on that too. Let's see, mounting the Zoomie could be a challenge. And let's go back to this guy, for example. Now, I'm not really hoping to use popsicle sticks for the end assembly. But right now I'm envisioning these QR codes to be on the road surface, and the camera would be looking downward. Reason I'm kind of favoring that, I've got that spacing, that distance already there. Now the problem with this is, of course, this body, let's use this one, it's a little tighter, has to fit over the top of this, like so. I gotta get wires and everything else to pass through there somewhat readily easy, because the bodies will most likely have to come off every time I use the Zoomie to gain access to the batteries for recharging them, etc. So I've got to come up with a way where I can mount the camera on here, and my thinking is right now it might be right in this area where it'll be on a device that I can push back in, lift the body off, put the body on, and then somehow grab a hold of it and then pull the camera back out on something that's similar to what I've got here. It'll be some tinkering around in Fusion 360 and a lot of fun at the 3D printer and perhaps some cussing and swearing. But I think I can come up with something to accommodate that. I do want to be careful about that, though, because I believe this shiny thing here is the Wi-Fi, and the less crap you got between that and my access point, the greater the probability is you'll have bad communications. So everything comes into play on this. But nonetheless, mounting be a little challenging. Not any more challenging than anything else I've done on this. As mentioned earlier, the QR codes, I could either place them on the road surface or mount them up on little signs that could be standing up off to the side of the road and have it, the QR code say where this label is, the camera's looking that way as he passes by, it could look at that. Getting vertical standing signs on the layout, I think, is going to be much more difficult than putting QR codes on the road surface. Plus, the other thing is, with 16 of these guys running around down there, or any amount of them, there's going to be times when I got to reach in and grab one quickly, and I know I'm going to be busting off signs and things like that. So I'm kind of favoring the look down at the ground methodology that we've got here. With all that said, there's problems. There always has been on this experiment, and that's half the fun of it. But this thing has a lot of potential for localization on what we're trying to do here. A lot. And before I spend it'll be about probably with tax close to $200 to buy enough of these to fit each of the Zoomies. That's with just one each. If I go with two each, I'm up at about $300. A lot of money, yes or no, it depends on who you are. I'm semi-retired, so money is a critical issue. But with that, I got some time in front of, you might be seeing that in the background over there. That is a large print, I think it's called a C-size print, of the ZoomTown. That's out of my CAD system where there's multiple layers and I got all kinds of details. And when I started thinking about this last week, I needed to have something I could take around, like up to my other office, and look at it and go, this is what I think we need for the magnets, for the tape, the markers, and all that stuff. Well, now it's helping me with thinking my way through this system. But rather than point back there on that one, I'll bring it up here on this computer. And here you can kind of see, and I don't think I've reviewed any of this with you folks yet, but these are the guidelines with the new tape that we're using, 1-inch markers, 25 millimeters. The red dots are magnets that I can tell the Zoomie when it backs out of a driveway and starts going this way, when it encounters this piece of tape and that marker, you are at a very specific position that I can tell you you are at. That gives me a tremendous amount of ability with localization and accuracy, by the way. The blue dot here is at a start of a line. So when the Zoomie comes along, encounters a black line and a blue dot, that is the 0 marker for that line segment. And all the way along that line segment, whether I park and come back out and continue or go all the way along that line, I am going to know very precisely where the Zoomie is during that duration. Where I will lose track of position would be on the sweeping turns, such as these, and there's only 8 of them, or the one-wheel pivot turns. That'll make a little more sense here as in the coming weeks. I don't know if this video will come out before those videos or not. I haven't figured that out yet, but it'll make more sense when we cover it. But a lot of these are all pivot turns going in and out of a driveway. And again, I'm going to lose positioning on that. It's going to be very hard to mathematically track that motion. So I'm pondering it in the wee hours of this morning today. At about 4 o'clock, I'm staring at a blank version of this without these green circles here, and I'm thinking, where can I put this? You know, I can't really be moving when I scan. Ideally, it's got to be where I stop and scan. Well, the very first place I thought of is every parking spot I'm stopped. That makes good sense. It has to stop in a driveway. So every driveway would have a barcode in it. QR code. Sorry, I'm old school. So that's easy, and that gets me 32 places of very precise absolute position location. And I'm staring at it, and then I started thinking about certain intersections, just like in the real world, are controlled intersections where you pull up to it and you must stop. Well, hopefully the Zoomies will be better than the people drivers and actually make a stop. And if they do, I could scan a QR code at each stop sign. And that would get us all these green circles all over the whole board. So I've got a bunch more positions that I can get very precise, accurate, absolute position data relative to one singular datum point on the whole layout. And then I'm pondering, how do I do that out here? Because I never really intended to do stopping out here. This is sort of like a bypass highway. The Zoomies were just intended to go along until they turned into a driveway, just turn and go into the driveway. Backing out, yeah, that's going to get a little more tricky, but nonetheless, that was my point of this outer perimeter, a bypass highway. And as I'm thinking about it this morning, I've got extremely precise capabilities along this whole distance. There, all the way around this whole thing. The only areas that would be imprecise, where I won't know where the Zoomie is, are on these two sweeping curves. So I may just simply slow down on the curves and have the QR code there and read it very slowly. Nothing wrong with that. Kind of looks silly, but There's going to be some silly stuff as we work through this. So all around, this sensor has just taken over a lot of the thought process of how to do everything and still maintain this localization. And you may not quite appreciate it yet if you haven't been following since the beginning, but localization is important for this one factor. On this layout, there's 16 Zoomies, all moving around at random times, going to random locations, and they can't hit each other. And in order for them to not hit each other, they have to have some awareness of where each other are. And all that data of where they are is in one central computer called the scheduler. And that's a Raspberry Pi 4 that all the Zoomies communicate to it, the positional data. Before I was just using encoder or our new system, our hybrid system positional data, but now I may be adding QR code to enhance that data to be even more accurate. That would give the scheduler awareness of where everybody is, and a Zoomie, whenever he needs to get into a position where he could hit somebody, he could ask the scheduler, is there anybody in that area, yes or no? If it's no, out he goes and moves along safely. So yeah, the importance of localization is critical to the success of this project. In the coming weeks or so, maybe a month or so out, I'm going to talk about another failure. It's an untested failure of an idea that I had working with localization, where watching one of the videos here on the test track a few weeks back, as I'm editing it, it dawned on me I made a horrible, stupid mistake. So we'll talk about that one in a future video. So I'm going to wrap this video up. I think we've got a lot of food for thought on this new, very cool, tiny code sensor from Useful Sensors. I just think it's cool as all get out, and I really kind of want to incorporate it in the system. If you guys got some thoughts, comments, suggestions, please throw them in the comments. It only serves to help all of us see a vision of where this whole project is going. Thanks for watching, and I look forward to seeing you in the next video.